Hey guys, welcome to the intro to logarithms. This is going to be just a very basic and short video. There is going to be a continuation of this afterwards, just to introduce you to other log laws. But basically, with exponential equations, I guess we're used to quadratics, we're used to linear equations, but then when we talk about exponentials and logarithms, we're wanting to work out what the exponent is, then logs is really going to help us. We understand that that is your base, and this is your index or your power, your exponent, and this is basically, you could say that it's your answer, okay, your result. But when we put it into log form, I'm just going to rewrite it for you. So we have log base a to y is going to equal x. So we're going, in terms of logs, then I would like you to see the color coordination, corresponding components. So here is when we figure out what the index is. That is your result, and this is your base, okay, in terms of what. So we're going to put it into, we're going to go through a number of examples to show you and get yourselves a little bit familiar and understand a little bit better of how all of this works. So I'll call this log form, and then this is index form. Okay, so just a few examples. So let's say if we had 10 to the power 4 is equal to 10,000. Okay, that's a very basic statement, and it makes sense. But if we have it into log form, if I ask you to change it into log form, we got log base 10. What is the result? 10,000. So 10 to the power of what gives you 10,000? The answer is 4. Okay. If I had log base 381 is equal to x, we're basically asking you 3 to the power of what gives you 81. Okay, so that is going to be 4. Okay, so that's just the rephrasing to help you understand what the logarithms do and how you could probably question and rephrase things to help you know where to go. So if we have 6 to the power of x, and that's 216, okay, and ask you to rewrite it into log form, you're going to have log base 6. The answer is 216, but we're wanting to know what x is equal to. So let's say if we had 4x equals 8, x is going to be 8 divided by 4. So this is just linear equations. This is what we're going to be doing to isolate x and solve for x using logs. So what we end up having here is that 6 to the power of 3 is going to give you 216. We have log base 3, but it's a third. We know that a third is the same as 3 to the power of minus 1. So basically, 3 to the power of what gives you 3 to the power of minus 1? Well, because the bases are the same, we can conclude that these are the same. So then x must equal minus 1. All right, next one. We have log base 28 is equal to 3. So 2 to the power of 3 is going to equal 8. Does that statement hold true? Correct. So then that is okay. So all we're doing is just reversing, going from log form back to index. And if you are familiar with index form, you want to make sure that both statements hold true. Otherwise, if it doesn't, then you've made a mistake somewhere along the way in translation. Log base 10, 1 over 100. Now, 1 over 100 is the same as 10 to the power of minus 2 in index form. So we can then say, well, 10 to the power of what gives you 10 to the power of minus 2. And again, because the bases are the same, we can conclude that these two exponents are the same. So x should equal minus 2. Log base 25, 5 is equal to a half. Rephrase it back to index form. 25 is your base. That is your power. This is your answer. So does 25 to the power of a half equal 5? Yes, because the square root of 25 is equal to 5. Okay, so hopefully that helps you guys, just getting a general start and kickoff to logarithms. Next video, we're going to look at the different laws and how you can apply them. Just making the connection with index laws and translating into log laws, going backwards and forwards using one and the other to help each other. All right. Any questions? Let me know. See you later.